Let's talk a little bit about some important stuff from grade 9. Okay, which is basically what this first lesson is. We're not reviewing all of grade 9. Okay, we want, like I told you guys, those of you that were here last year, big focus of grade 9 is algebra. We're going to continue with quite a bit of that in grade 10. So what I would like to do today is do part of lesson 1.1 and review some of the algebra we did last year. Okay. So we worked with powers. What's power? It's an expression that represents repeated multiplication. Students often call them exponents. It's made up of a large number and a small number to the upper right. The whole thing is called the power. Okay, it's actually just the little number that's called the exponent. And the big number is the base. So what do we do when we see a power and we're asked to evaluate or find the value of it? Well, this just means take the number 5 and multiply it by itself 3 times. So 5 times 5 times 5. Okay. I'll only throw this in here just so that you guys are familiar. When I use words like power and exponent and base, you know what I'm talking about. Okay. One of the big things we did last year, okay, is we worked with expressions, algebraic expressions. So what's an algebraic expression? It's a math statement that has a variable in it, an unknown, usually a lowercase letter. It can also contain numbers. It can also name operation signs, addition, subtraction, multiplication, division. It could also contain exponents. Okay, and if it does contain plus and minus signs, we call each of the I don't know what you call each of the things between the plus and minus signs terms. So, like for example, this is an algebraic expression that has numbers in it, constants, it's got a variable, it's got an exponent, it's got a subtraction. Okay, it's actually got a multiplication in it too because we've got the 5 and the x beside each other. Okay, so that's an algebraic expression. So there's one subtraction sign, which means there's 2 terms. One of the terms is 5x squared. The other term, you got to take the negative with it, minus 3. X is the variable. Negative 3 is the constant. Okay? Because it's by itself, it doesn't have a variable attached to it. The 5 that's in front of the x squared, which means these two are being multiplied, we call a coefficient. Okay? Again, you don't have to write definitions of these words. All I'm doing is throwing them back out there again, just so that you're familiar with the words when we use things like constant and variable and coefficient. You know what I'm talking about. So what do we do with the expressions? Well, we evaluate. If we're given one, we're told the values of the variables, and then we calculate the expression or evaluate. So we did a lot of this last year. For us to evaluate these expressions. 4x minus y plus 10. And we're told that x is 4 and y is negative 3. Okay. First of all, look at this expression. How many variables are there? 2. 2. X and y. Okay. Tell me a coefficient. 4. Well done. Tell me a constant. 10. Tell me how many terms are in this.
3.
3. Good. Okay. So you should be familiar with that. But the more important thing is we want to evaluate that. So what does this mean? That means when we see x, we replace it with 4 and put parentheses around it. So there's a 4, and then I do parentheses 4. Then there's a minus, and then I do parentheses negative 3. and then there's a plus 10. So now I've got all numbers, I just calculate using proper order of operations. 4 times 4. This becomes plus 3, plus 10. So it's actually 16 plus 3 plus 10, 29. That's our final answer. Okay. This one's a little bit more complex. Because we've got some exponents and we've got variables in more than one place. So we've got an x, so automatically I replace that with 3 in parentheses. Then we've got a y, I replace that with -2 in parentheses. And then there's an exponent after that, -2, and then there's an x, which means I put parentheses 3, and then that as an exponent to the third. Remember, order of operations. What do I do first? I've got some can you see we've got some multiplying going on? We've got some exponents going on. We've got a subtraction going on. Which of those do I do first? The exponents. So 3 times whatever this answer is. Remember, parentheses. What is -2 in parentheses? Squared. +4. Minus, because the minus is going to get done last, 2 times whatever 3 to the third is. 7. Exponents are gone. Multiplication is next. This becomes 12 minus 54. And 12 subtract 54 is going to give us -42, and that's the final answer. Okay. So we use evaluating expressions a lot. Whenever you use a formula for anything, you are doing algebra. You are evaluating expressions. I mean, if you're figuring out a grocery bill, that's algebra. You're doing algebra. Okay? You're plugging in whatever the cereal is. You're plugging in whatever the bread is. Now, sometimes we get expressions that we can make easier before we evaluate. Evaluating expressions is the goal. But sometimes, like if I told you x was 2 and y was 3, well, you could plug 2 and 3 in here and 2 and 3 in here and do all the calculations. But mathematicians are lazy. They like to simplify things. Instead of doing all those calculations, is there any way I can make this easy before I do the calculations? Yeah, I can combine the x's. I've got a 6x and a -2x. That makes 4x. I've got a 3y and a 10y. That makes 13y. I can't combine the x and y's because they have different variables. So these two expressions are the exact same thing. But this is a heck of a lot easier to work with. Okay? This is a pretty complicated one because it's got some exponents in it. You got to remember like terms. Okay. We're not doing any exponent laws yet. We're not adding exponents or subtracting exponents or multiplying exponents. Think of it this way. We've got like terms here. I've got 3x cubes and 2x cubes. Well, what's the easier way to say that? 5x cubes. I've got -8x squareds and 9x squareds, positive 9x squareds. 1x squared, or you can even write just x squared. If you put the 1 there, that's fine too. I've got negative 3x's and negative 6x's. Negative 9x. And I've got some numbers, some constants, 3 and 1. Notice I did not combine these. Yes, they have x's in them, but the exponents are different. When you are adding and subtracting things, they have to have the same exponents. Only when you multiply or divide or raise one power to another power, that's when you can work with the exponents. Like here. Okay, this is adding and subtracting. This is something different we're doing now. We're multiplying powers. So this is one of the 3 main exponent laws. When you multiply 2 powers, they have to have the same base. Otherwise, you can't multiply them together into a single power. So if we've got x to the something times x to the something else, I can combine that x to the whatever the sum of the exponents is. If I've got coefficients in front, I multiply the coefficients together and then I add the exponents. So here, notice all of these, the bases are the same. What would x to the 4th times x to the 5th be? X to the 9th. Because we add the exponent. Base stays the same, we add the exponents. Be careful with this next one. You're multiplying powers. You don't multiply the 7s. Base, they're bases. They stay the same. So what's our simplified answer? 7 to the 9. Okay. We won't see many like that. The bases will usually be variables. Well, we've got more than one variable being multiplied here. First of all, is my answer going to be positive or negative? Negative, because I've got, like, think of it like negative 1 and 1. So negative 1 times 1 is going to be negative. Now multiply the a's together. What do you get? A to the 5th, because we add the exponents. Which means we could get b to the 12. And that's as far as I can go. We got some coefficients in this one. So let's take care of the coefficients first. What's negative 7 times negative 3? 21. And t to the 4th times t. T to the 5th, right? Because t is the same as t to the 1st. So there's actually 5 t's being multiplied by each other here. So we get 21t to the 5th. Next one, let's take care of the coefficients. Remember, they get multiplied. 2 times negative 5, negative 10, and then somebody finish it for me. X to the 8, y to the 5th. Because we add the exponents of the x's, add the exponents of the y's. And then it's all multiplied together. So that's why we write them beside each other. So multiplication is one of the exponent laws. So remember, be careful. What's this? Or tell me this one first. Give me one of them. Top one's 4x squared. Bottom one is 2x to the 4th. 4x to the 4th. See the difference. We're adding the first one, we're multiplying the second ones. Okay, so just know the difference between those two. Okay. One more multiplication. Well, we've got a term on the outside and inside parentheses. We've got three terms. If they're side by side, multiply. How many multiplications am I going to do? Don't I have to take the 5x and run it through everything? So I'm going to do three multiplications. So I'm thinking exponent laws. Remember, 5x is the same as 5x to the first. And x over here would be the same as x to the first. So what's 5x to the first times x to the third? Well, 5 times 1 is 5. What's x to the first times x to the third? X to the fourth. We don't have to worry about an exponent law in this second multiplication. It's just 5x times 3. So it's 5 times 3 times x. 15x. Here, it's going to be minus. 5 times 1 is 5. What's x to the first times x to the first? X squared. I can't combine them after that because they all have different exponents. So that's as far as I can go. Okay? So again, I gave you an example of this, but remember the difference. X plus x is 2x. X times x is x squared, because you got to think x to the first times x to the first. We can divide powers too, as long as the bases are the same. We can divide them into a single power. Okay? Well, when we multiply powers, we add the exponents. It kind of makes sense that if we divide powers, we subtract the exponents. So if they have the same base stays the same, you just subtract the top by the bottom. If they have coefficients in front, you divide these two numbers, and then you perform the exponent law on that. So what would this one be? Yeah, x to the first, or just x. I'm going to accept that. How will b? 7 to the 4. So every time I scroll, diagonal segment. Well, we've got to think of this as -1 divided +1, so that's going to give us -1. Negative. And what happens when we divide the y's? Y to the third. What happens to the z's? Yeah, they cancel each other out because if you think about it, well, z to the third divides z to the third. Anything divided itself is 1. So it would be -y to the third times 1. Well, I don't have to write times 1 because it's the same thing. So that's why we can say they cancel out. And I don't have to write anything. How about this next one? Yeah. Divide 18 by -3, you get -6. Then do your division exponent law to get m to the third. Here we got to do divide numbers, division exponent law, division exponent law. So we got to do 63 divide 7, then a to the 5th divide a, then b to the 8th divide b to the 3rd. And remember, A is the same as A is the first. So what would my final answer?
Wait, I had a question.
Yeah.
Because for this one, the bottom one, the A and B are together, like the top one, they're separated, so.
Oh, no, they're still separated on the bottom. We just don't write the 1. Because if you put the 1 in there, you could say they're separated, right? Yeah, so they'll always be separated. No, good question. And the last exponent law we looked at. What happens when you take one power and you raise it to another power? You multiply the exponents, right? What happens if there's a coefficient inside with it? Well, you've got to take that number and raise it to the exponent, and then do the power of the power law. That's something that students often miss, so you got to be careful with that. Well, this one, k to the third time, or sorry, k to the third to the fourth, k to the 12th, 5 to the second to the fifth. Base stays the same, so it's 5 to the 10th. You don't raise that 5 to the 5th. Don't go 5 times 5 times 5 times 5. It's 5. These next two. Remember, this means you've got to go 3 to the third, and then we're going to multiply that by p to the 5th to the third. So this isn't an exponent law. 3 to the third is 27. This is an exponent law. 3 to the 15. And for D, just remember we're going to lie by itself, so I'm just going to attach an exponent of 1 to remind myself when I do exponent laws. Somebody want to take a shot without me saying anything?
Negative 4x power to the 12th, and y to the 10th.
Would you like to change part of your answer? You're mostly right. There's just one little thing.
Oh,
You did the X's and Y's correctly. So this is good.
well, it's gonna be negative 8.
Careful. -4 squared. Multiply.
No, 16.
Good. Good job. Well done. 16. Okay. Stop, yes. That's very sensitive today. Okay, I'm going to stop there because I think that's a good place to stop, because if we jump into equations right now, that's loading you up with a lot of stuff. All right, so this is sufficient for now.